This videotape will show you 3 methods of turning tapers on a lathe. Taper is defined as a difference in diameter as you measure along the length of a part. After viewing this tape, you should be able to describe the safety procedures for machining tapers on the lathe, list different types of tapers and their common uses, calculate inches of taper per foot and degrees of taper, and describe the procedures for machining tapers by the offset tailstock, compound rest, and taper attachment methods. Before beginning, perform the required safety procedures by wearing safety glasses, removing jewelry, and keeping sleeves above the elbow. Always check the work setup for clearance before engaging the clutch. There are generally 2 types of tapers: the soft holding tapers and the steep self-releasing tapers. The soft holding tapers generally do not exceed 2 or 3 degrees, so the shank of the tool is firmly seated in a matching socket. This match gives tremendous frictional resistance to slippage and may have a tongue drive as well. Soft holding tapers on lathe mandrels have a taper of 1/2 thousandths to the inch. On Morse taper drill shanks, the taper is approximately 5/8 inch per foot. And on tools with a brown and sharp taper, the taper is approximately 1/2 inch per foot. These soft holding tapers are used for arbors, collets, machine tool spindles, and for many other applications you can find in the machinery's handbook. The other kind of taper is the self-releasing or steep taper. These tapers usually exceed 16 degrees and require a positive locking device to prevent slipping. These tapers release very easily and are generally used on machine arbors. There is an American Standard Steep Machine Taper series which is charted in the machinery's handbook. The offset tailstock method is frequently used to turn long, slow tapers. When the tailstock center is offset by moving the tailstock out of alignment, the center line of the work and the line of travel of the turning tool are no longer in parallel, and a taper will be turned on the work. To calculate the amount of offset for the tailstock, you determine the amount of taper per inch to be machined. The specification on this operation is 5 thousandths of taper per inch on a workpiece 8 inches long and 1 inch in diameter. We will machine the taper to a length of 6 inches with a diameter of 875 thousandths, 1 1/4 inches in from the end of the work. Using the formula, tailstock offset equals taper per inch divided by 2 times the length of the work, and you get an offset of 20 thousandths. Place the 8-inch workpiece in the machine for turning between centers. Set up a dial indicator on the tailstock end of the work. If the work has a smooth surface, run the indicator along its length to check for taper. This piece has no taper, so we are ready to offset the tailstock 20 thousandths. Move the dial indicator to the tailstock end of the work. Set it to 0. Loosen the tailstock clamp and turn the adjusting screws to move the tailstock center 20 thousandths. Lock the tailstock and check the spindle for adjustments. When work of a different length is placed between centers, a new offset will be required to cut the same taper per inch. Remove the indicator. Now set up the tool post. In this case, we will use a right-hand finishing tool in a left-hand holder. The finishing tool will give us a smooth finish and allow accurate checking of the taper per inch. Set the tool precisely at center height or you will not cut accurate tapers. Set the spindle RPM for finishing. And set the feed rate to finishing feed. Engage the clutch and blew the work about 6 inches from the end. Set your hermaphrodite calipers to 6 inches and lay off the length of the taper. Pick up the cut on the end of the piece and take a 30,000th depth of cut. This will remove 60 thousandths from the diameter of the work. Remember, the work has a 1-inch diameter, and the finished specification is 875 thousandths with the taper. Complete the cut to the 6-inch mark. When you get close to the mark, disengage the power feed and feed the tool by hand to the mark. Do not remove the tool from the work. Blue the work approximately 3/8 inch from the tailstock end. Then blue it every inch or so along the length of the taper. Set the calipers and mark the work at 1/4 inch, 1 1/4 inches, 2 1/4 inches, 3 1/4 inches, and 4 1/4 inches. Then, disengage the clutch. Using the outside micrometer, start at the 4 1/4 inch mark and measure the diameter. Write it down. Measure the 3 1/4 inch mark and subtract that reading from the previous reading. Continue this way until you have measured and subtracted all the diameters. These readings all show a difference of 5 thousandths, so we are on our specification of 5 thousandths per inch of taper. If the readings do not meet these specifications, unclamp the tailstock and use the adjusting screws to correct the amount of taper. Take another cut and measure every inch to check the taper until you meet the specification. Since this piece has the proper taper, we are ready to finish it to the specified diameter of 875 thousandths. The micrometer reading at the 1 1/4 inch mark is 936 thousandths. By subtracting 875 thousandths, you get a figure of 61 thousandths to be removed from the diameter. Now you use the carriage hand wheel to move the tool to the end of the work. Do not move the crossfeed away from the work. When the tool bit clears, feed the tool in to remove 61 thousandths from the diameter. Engage the clutch and longitudinal feed and turn the work to the 6-inch mark. Use the carriage hand wheel for the last part of the cut. Blue the work 1 1/4 inches from the end. Set the calipers and mark 1 1/4 inches from the end. Disengage the clutch. Measure the diameter. This diameter measures 876 thousandths, so it is within tolerance. This completes the turning of a taper with the offset tailstock method. The compound rest is generally used for cutting short, steep tapers, since its lead screw has limited travel. The work is usually held in a chuck for these steep tapers. The compound rest can be used for internal as well as external taper turning. For this demonstration, we will cut an 82-degree included angle on the end of a workpiece, leaving a 1/4 inch flat diameter on the end of the work. Set up the piece in a chuck, leaving enough material extended to cut the angle about 1.5 inches. Face the end square and blue it. The bluing will help with measuring the 1/4 inch flat diameter. The compound is always set to cut 1/2 the included angle. So 82 degrees divided by 2 equals 41 degrees. So the compound setting will be 41 degrees off the machine's axis. Turn the compound parallel to the machine's axis. Then move it to 41 degrees. Lining up to a reference point and then making the setting will eliminate mistakes. Now, lock the compound in place. Set up the tool post with a right-hand finishing tool in a left-hand tool holder. This machining is the same as straight turning. Set the tool point at center height. Set the spindle RPM for finishing. Check the compound travel to make sure it is adequate. About the center of the lead screw is a good place to start. Engage the clutch. Pick up the corner of the work with a tool point. Using the compound travel, move the tool to the end of the work and take a depth of cut with the cross feed. Now take the cut as you would in straight turning, feeding the tool by hand with a compound hand wheel. Repeat the cut, taking 30 thousandths to 50 thousandths with each pass. Continue until there is about 1/2 inch of diameter on the end of the work. Disengage the clutch and move the tool away from the work. Using a protractor head and ruler, measure the included angle. If you have difficulty measuring the included angle, use any of the other angles to check it. We will use the end of the work. The angle is 41 degrees off the axis, which would leave 49 degrees off the perpendicular or face. Set the protractor to 49 degrees and check the angle. This angle checks okay, so we are ready to machine it to size. Engage the clutch and machine the piece until you reach the specified 1/4 inch diameter on the end of the work. You can stop the work occasionally to check this diameter with a 6-inch rule. This diameter is 1/4 inch, and the angle is 41 degrees, giving us an included angle of 82 degrees. This same procedure can be used for machining internal tapers by drilling a hole to the taper depth and using a boring bar for the cutting tool. The third method of machining tapers is with the taper attachment. The taper attachment is used for machining both internal and external tapers. It has a good deal more travel than the compound, but the angle it can cut is limited. The taper attachment method is more desirable than the offset tailstock method because the lathe centers stay in alignment and pieces of different lengths can be cut to the same taper without changing the setting. Prepare a workpiece with a diameter of 1 inch and a length of 6 1/4 inches for turning between centers. Select a finishing speed and feed rate. Set up a right-hand finishing tool in a left-hand tool holder for straight turning. The part to be machined is a number 3 Morse taper plug gauge, the dimensions of which are found in the machinery's handbook. The small diameter is 778 thousandths of an inch, and the tapered body length is 3 7/16 inches. From the table, you can see that a number 3 Morse taper has 50 thousandths of an inch of taper per inch. So the length of the taper times taper per inch plus the small diameter of 778 thousandths equals the large diameter of 941 thousandths of an inch. The workpiece diameter of 1 inch is therefore adequate. Position the taper attachment so the travel will be in the center of the taper attachment guide bar. Tighten the locking bolts on the clamp. The taper attachment will now feed the tool parallel to the guide bar. Loosen the locking bolts and set the attachment to 600 thousandths. The taper attachment is graduated in 1/16 of an inch, so the setting will be just under 5/8 inch. Lock the locking bolts. Engage the clutch. Pick up a cut on the work. Then move the tool toward the tailstock as far as you can without touching the center. This procedure takes the backlash out of the taper attachment and prevents a straight length at the beginning of the taper. Take a 50/1000th depth of cut and engage the longitudinal feed. Continue the cut until the tool leaves the work at the headstock end. Stop the machine. Return the tool to the tailstock end. A taper attachment has backlash, so you have to stop the machine to keep from cutting the work as you return the tool for another cut. Engage the clutch. Blue the machine surface 1/4 inch in from the end, 1 1/4 inches from the end, and 2 1/4 inches from the end if you have enough machined length. Using hermaphrodite calipers, mark the workpiece at 1/4 inch from the end, 1 1/4 inches, and 2 1/4 inches. Measure the diameter and subtract to determine the taper per inch. If the taper is within tolerance, machine the part to size. This piece measures 48/1000ths of an inch of taper per inch, which will require adjustment of the taper attachment. Loosen the locking bolts and adjust the guide bar, taking care to move it in the right direction. You can hold your hand over the guide bar to detect the direction of movement for fine adjustments. Lock the locking bolts. Now, take another cut. Mark the diameter every inch, beginning 1/4 inch from the end of the work. Measure for taper per inch. This time the reading is 50/1000ths taper per inch, so we are ready to machine the small diameter to size. The diameter will have to be measured 1/4 inch from the end, since you cannot measure directly on the end. Divide 50/1000ths by 4 to determine the amount of taper in 1/4 inch. This comes to 12.5 Add 12.5 to 778 and the diameter 1/4 inch from the end should be 790 The diameter at the 1/4 inch mark is 820 so you have 30 to remove from the diameter. Set the depth of cut and take your final cut. When the diameter is finished, disengage the clutch. Move the tool out of the way and remove the work from the machine. Check the work for size using the outside micrometer. This piece measures 791/1000ths, which is within tolerance. If the piece does not meet size specifications, replace it between centers and finish it to size. To review briefly, you should now be able to describe the safety procedures for machining tapers on the lathe, list different types of tapers and their common uses, calculate inches of taper per foot and degrees for machining tapers, and describe the procedures for machining tapers by the offset tailstock, compound rest, and taper attachment methods. You have now been introduced to the basics of turning tapers on a lathe.